Hi, welcome to the last video for AP Physics C Mechanics. So once we're done with this, you've completed the curriculum and you should celebrate, right? And then focus on electricity and magnetism if that's how you go. And so here in this video, we're going to look at the orbits of planets and satellites. So you may seem like I'm going to be rushed because I don't want to show a lot of the derivations on some of these equations. But if you are interested, you can make a comment below or reach out to me in some way, and I can provide those. So the first thing is that when a planet or satellite is in orbit, the angular momentum is going to be conserved. So again, they may have, talk about 2 points in the planet, ask you for a speed at 1 point. But we're going to treat it as a point charge. So we're just going to simply do, or not charge, a point mass. So we may have to do something along these lines, MVR sine theta. But the main thing is if it's all in alignment, it's just MVR. If it's not, then you have to include the angle. Now, just like objects on the planet, the mechanical energy will also be conserved, and because it is a conservative force, we can use the integral, right, our integral equation to determine the potential energy by simply doing U equals negative integral of F dx dr, whatever you want to call it. So this is the gravitational potential energy. This is going to be different than MGH, okay? If the object that you're looking at is an infinite distance away from the central object, then this equation, this UG equals negative G M1 M2 over R, is just simply 0, right? Because if this number is big, right, you're going to have a relatively small number up top. Big over or small over big is essentially 0. Now, something you may also be asked to find is the escape speed. So this is one of those equations where I'm going to write it down, but I'm not going to show you the derivation, okay? So the escape speed is the minimum speed needed to leave the gravitational pull, okay? And so anytime you see R, again, remember, it's the distance between the centers. And so the escape speed is square root of 2gm over R. In fact, because this will be at the surface of the planet, this is the radius of the planet. Okay. The last thing, you've already seen the derivation if you watch the previous video focused on gravitational forces. So the centripetal force is what keeps the planet in orbit. But remember, the centripetal force is not a force like U or F sub G or friction or any of those forces. It is a net force. So that is what creates the circular path. To determine what is called the tangential speed of an object in orbit is simply square root of gm over r. In the last video, we got to a point where it's v squared equals gm over r, but we were actually looking for the mass of Mars and not the speed of the object. They actually gave that to us. And then the last thing is not touched on a lot, but sometimes it pops up every once in a while on the test, and that's Kepler's laws of planetary motion. And Johann Kepler developed these set of laws that govern the motion of the planets. Right? He used some research. There's a very interesting story about him and his mentor. And so he developed 3 laws. The first one is the law of ellipses, and these laws are representative of the pictures that you see on the screen. The law of ellipses essentially states that all the objects that orbit the sun or the central object in an ellipse, okay, with the central object at one focus, which leads to it's closer to the sun. The Earth is closer to the sun at some point in time, and it's further away from the sun at other points in time. Okay. The next one there, kind of to the right, middle right, is what's called the law of areas. And so what that means is equal areas are swept out in equal time intervals. Even though the shapes, like you see when the planet's furthest away from the sun, the shape is more elongated versus when it's closer to the sun, but those areas are equal. And then the last one is the law of periods. And what this basically says is that the square of the period is essentially the rate, is the distance, is a T squared is proportional to R cubed. And this is kind of the governing body to that, where this is a constant, right? It's sometimes called a Newtonian constant or something, I think. But those are the basic things about the orbits of planets and satellites. And so let's look at the most common question that you see on the AP Physics C test will be something to do with the energy. Okay, so let's look at an example involving energy. So basically the same question that we had in the last video, but we're going to look at, instead of looking at the speed and the radius of orbit, we're going to look at the mechanical energy of the satellite in orbit. And so we're going to do energy is K plus U. That doesn't change if it's on the planet, off the planet, or somewhere. It's always going to be K plus U. And so the only difference is now we're going to look at that gravitational potential energy, the universal gravitational potential energy, not MGH. So it's going to be 1/2 mv squared. And in fact, this is not going to be a plus. This is going to be minus because our equation has a minus. So minus G m1 m2 over R. Okay, and that's what we're going to use to find it. And so now we just plug in numbers, right? That's how straightforward this is. So 1/2 times 930 times 3400 squared minus 6.67 times 10 to the negative 11th times 930 times the mass of Mars that we calculated, 6.64 times 10 to the 23rd, divided by the distance between their centers, which is 3.83 times 10 to the 6th. I think it was the other question that the other part of the question that we were asked to find. And so you end up with, the first part is 5.38 times 10 to the 9th. The second part is 1.20 times 10 to the 10th. So something you know, this answer is going to be negative, and that's okay, and I'll explain it here in a second. And so it's going to be negative 5.42 times 10 to the 9th joules. And what that negative sign means is that the satellite can't leave the orbit. Okay, that's what that negative sign means, and that's perfectly fine that we got a negative answer here. Okay, so with that calculation, we are now done with AP Physics C Mechanics. If your teacher or moves is already done E&M, I would say good luck on your test, because that means they're coming up. Or the way I do it is we'll do E&M here in the second semester of the school year. Okay, it's been fun teaching mechanics. Now let's go get that E&M.